Hi everyone. In part one of this video, we talked about simplifying just general rational expressions. And in part two, we're going to go on to multiplying and dividing rational expressions, or multiplying and dividing fractions with variables in them. Before we talk about rational expressions, we're going to review how you multiply or divide fractions with just numbers. So starting with multiplying, all you do to multiply fractions is you multiply across the numerator and across the denominator and rewrite it. So in this fraction, if you have 3 over 4 times 2 over 9, you'd multiply 3 times 2, which is 6, and that would be in the numerator. 4 times 9 would be 36, and that would be the denominator. And that's how you multiply them. Now, the kicker about multiplying is you have to make sure they're fully simplified at the end, and you're going to have to use part 1 to do that by looking for a common factor in the numerator and denominator. So what can you divide both 6 and 36 by? Well, I know they have a common factor of 6, because 6 is 6 times 1, and 36 is 6 times 6. And since you have two factors of 6, and 6 divided by 6 is 1, those cancel. You divide it out, simplify, get 1 over 6. So if you remember how to do multiplication and simplification with numbers, doing it with rational expressions and variables is not so bad, I promise. Okay, we're going to do the exact same thing with these 3 problems right here. One thing I did want to note first, though, is some of you might have noticed at the beginning that there were some common factors that you could cross-cancel, and I want to show us how to do that real quick, because that may be how I do some of the problems on the right. So if you noticed that when you're multiplying these, right, this is really 3 times 2 over 4 times 9, and you notice that 3 and 9 have a common factor, and so do 2 and 4, you could start by simplifying to make the problem a little bit easier, the number smaller. So if common factor between 2 and 4 is 2, so 2 divided by 2 is 1, 4 divided by 2 is 2. Common factor between these two is 3. 3 divided by 3 is 1, 9 divided by 3 is 3, 1 times 1 is 1, 2 times 3 is 6. You could have simplified first and then multiplied. Okay, if this concept is super foreign to you with numbers, let me know. Otherwise, I may repeat that process when we have variables. Because right now, as I'm looking at this, I know I'd multiply across the top and across the bottom, but those numbers are pretty huge, and I don't know what 84 times 48 is off the top of my head. Okay, I do know that generally speaking, I would multiply across the top, so I'd get 84 times 48x over 3 times 95. Okay, so that's generally speaking what I'm going to do. I could use a calculator to multiply, then simplify, or I can try and simplify first and say, do any of these have common factors that I can simplify before I multiply? So I actually know that 84 can be divided by 3. 84 divided by 3 is actually 28. So if you take 84 and you divide it by 3, you're going to get 28. If you take 3 and divide it by 3, you're going to get 1. So I've already been able to simplify a little bit by pulling out a common factor. So that's the only factor I know off the top of my head. And sometimes I think it's helpful to just kind of write it out as a factorization to see if there are any other factors that can cancel. So for example, I know 28 is 4 times 7, and you're multiplying that by 48x. I know 48 is like 2 times 24, okay, and you're multiplying that all by x. So I've just kind of broken this down into its factorization, getting closer to its prime factorization. The denominator, we just have 1 times 95 left. 95, I think, is like 5 times 19. Okay, now that I've written these numbers as products, it's a lot easier to see if there are factors we can cancel. And unfortunately, it doesn't really look like there's anything that can happen. 5 and 19 are prime. It doesn't go into like 4 or 7 or 24 or anything. So unfortunately, there are no 2 factors in common, which means this was actually as simplified as it could get in the numerator. You'll just have to multiply across the numerator and denominator here. Even though they're big numbers, well, honestly, I'm going to use my calculator right now. So in the numerator, you are going to end with 1,344x. In the denominator, you have 1 times 95 is 95. And that's it. That's literally all you can do. And it's okay if you get big numbers or weird answers or whatever. Just be confident in your process. Okay, so mostly multiplying fractions, just multiply across the top and bottom and simplify anywhere you can. Okay, which brings me to this next problem. We've got a lot more fraction variable situations happening here. Let's break this down. Okay, just because it looks different, looks a little bit ugly, doesn't mean you treat it differently. That's the main thing I want you to know here. All you do when you multiply fractions, right? So here we are multiplying, is you multiply across the top and across the bottom. Okay, now I'm not going to actually do the multiplication. I'm just going to write the multiplication first. Okay, so in the numerator, you'd be multiplying these three things together. In the denominator, we would be multiplying these four terms together. And note that I gave this to you in factored form because once it's factored, as we learned in the previous video, it's all just one big product. And if you have it as a product, you can divide to cancel things out. Anything that's the same factor, such as in this problem, I have an n plus 4 in the numerator and denominator, and anything divided by itself is 1, so those would cancel. I also have n minus 3 divided by n minus 3. Anything divided by itself, that simplifies. Okay, those are the only factors that I have in common. So all that's left in the numerator is 7n squared over n plus 8 times n plus 6. Okay, you can't factor any of that further. There are no other common factors. Okay, but you simplified the ones I have in common, and this is a lot simpler of an expression than the one to the left here. That'd be your final answer. Okay, I gave this one to you in factored form. That won't always be the case, such as in number 3. Okay, so you have this fraction multiplied by this fraction, writing multiplication in different ways, so it's either the dot, the parentheses, the star, it all means the same thing. Okay, now, this is going to be the same process where you just multiply across the top and across the bottom. So you'd have x squared minus 25 times 14x minus 7, similar thing in the denominator. Okay, the difference is I didn't give it to you in factored form, and in order to be able to cancel things out, you want to make sure it's fully factored into this most simple product to see what actually, what common factors exist. So what I want you to do is I want you to factor 1, 2, 3, 4, all of these terms. Just factor it, and I'll come back and show you how to simplify. No peeking. Okay, if done correctly, these are all the factorizations. So here's the first one, number 2, number 3, and number 4. Okay, wrote it out as one fraction because you just multiply across top and the bottom. But note, the dot means the same thing as multiplication. You could also put in parentheses. So all these things next to each other are being multiplied together, which means that any common factors can be divided and simplified, such as you have a 2x minus 1 in the numerator here, and 2x minus 1 divided by 2x minus 1, that's going to give us 1, so those cancel. You have an x minus 5 here, and an x minus 5 here. X minus 5 divided by x minus 5 is 1, so those will cancel. So all you'd have left in the numerator is 7 times x plus 5, which I'm going to switch the order around just because I think that looks nicer. 7 times x plus 5 is the same thing as x plus 5 times 7. And in the denominator, you have 2x plus 1 times 2x plus 1, which you could write 2x plus 1 times 2x minus 1, but I'm going to write it like this because a squared means you multiply it 2 times since it's the exact same thing, the exact same base. And this would be your final answer. You do not need to go and multiply this out or anything because our goal is just to simplify. I didn't say it needed to be in standard form. You could just leave it. But the main goal is essentially to multiply these, you're going to factor and then cancel stuff. By canceling, you're dividing. The reason you need to factor those to see what common factors exist. And if it's not written as a product, you may miss that there's actually a common factor of x minus 5 here. If you have any questions about the factoring, definitely come and see me. Otherwise, that's how you multiply. So we're going to move on to dividing. So dividing is luckily very similar to multiplying. That's why I'm doing them together here. Okay, what you need to know is that when you divide fractions, it's equivalent to multiplying by the reciprocal of the denominator. Okay, if you've never heard the word reciprocal, it just means the fraction flipped. So let me give you an example of that. So if you have the fraction 3/4, right, the reciprocal of 3/4 is 4/3. And you might be wondering why that is. You may have heard this before when you worked on just fractions in general, but let's review that right now. Okay, so you have fractions being divided here. It's 1 over 1/2, a fraction within a fraction, if you will. Okay, I like to do a visual explanation of why it's multiplying by the reciprocal. So let's draw this box here. Let's say you have one box. That's the 1 here. And you divide it into 1/2 pieces. So let me divide that into halves. What this is really asking is if you take 1 and divide it into halves, how many pieces do you have? Well, you'd have 1 piece, you'd have 2 pieces. So the answer to 1 divided by 1/2 is 2. Okay, or what you really did is you took 1, technically the fraction on the numerator is 1/1, and you multiplied it by the reciprocal of 1/2, which is 2/1, which gave you 2. All right, 1 times 2 is 2. Okay, that's the visual representation. The numeric representation is this. Okay, if you don't like the fraction and the denominator, what can you multiply 1/2 by that would cancel it out? Okay, then the answer would be 2/1, because 1/2 times 2 is just 1. Whatever you do to the bottom, though, you'd have to do to the top to keep it balanced. Okay, so in the denominator, these guys would cancel out. You just have 1. In the numerator, you'd have 1 times 2, which is 2, which still gives you 2/1. Okay, so that's the explanation for why dividing fractions is equivalent to multiplying by the reciprocal of the denominator. But that's the explanation with numbers. Let's go and apply that to rational expressions. Okay, so I wrote this a little bit differently with the division sign instead of as a fraction, but you're taking b squared minus 2b minus 15 over 8b plus 20, dividing it by 2 over 4b plus 10. So I could write it like this as well, different ways of representing it. Okay, and dividing fractions is equivalent to multiplying by the reciprocal of the denominator. So the first thing you want to do when you're dividing is rewrite it as a multiplication problem, just like I did over here. Okay, so this fraction is the numerator, and in order to divide them, you multiply by the reciprocal of the denominator. So you're going to flip that fraction and multiply. So it's going to be 4b plus 10 over 2. That's the reciprocal. Okay, once you rewrite it to be a multiplication problem, you're going to complete it exactly like you completed the problems up here, where you multiply across the numerator and across the denominator. You'll have to factor to be able to cancel things, just repeating that process. So that's what I want you to do. I want you to take this problem, and I want you to try simplifying and getting your final answer on your own. Okay, so factor, 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 multiply, cancel. I'll come back with the answer. No peeking, no cheating. Try it on your own. See what you can come up with. Okay, rewrote it a little bit, but I showed my work and I factored each of the 3 pieces. The only piece that couldn't be factored was the 2 here. Then I rewrote it as one fraction where you multiply across the top and across the bottom. Then you'll see I canceled by dividing the common factors, right? So 2 divided by 2 is 1. 2b plus 5 divided by 2b plus 5 is also 1, so those cancel out. And all you're left with is b minus 5 times b plus 3 over 4, which you can totally leave in factored form. You don't have to multiply this out, and there's nothing else that can be simplified. So just circled my final answer. Okay, so once you rewrite it, it's just like multiplication. So I guess we can conclude and say that's how you will divide and multiply rational expressions. If you have any questions, let me know. Otherwise, have a good rest of your day.